wonderful stuff.
Yeah, sure. So, my name is Jade. I study geology at Victoria University of Wellington. Um, at the moment, I'm actually working full time for a seismologist. So I'm doing a bit of my own research into New Zealand's geology.
That's
That's been
cool.
pretty fun. So I'm going to see if I can. I did make a slideshow, so I'm going to see if I can get that
Yep.
visible.
Super. There we go. Amazing.
Cool.
Fantastic.
So today I want to talk a little bit about the history of New Zealand because I think it's really fascinating. So I'm not going to try and go into every single rock in New Zealand. As exciting as it would be, there's a lot of rocks. So I did want to talk about where New Zealand actually comes from, which I
Yes.
think is a really interesting story. Particularly, a lot of people might not know, but New Zealand is relatively young, geologically speaking. So only maybe the last around 500 million years. So I'll get started, if that's is that all right?
Yeah, absolutely.
Yeah, I can see it.
So this, I guess, wanted to just show New Zealand and the sort of setting it's in. Hopefully, if you see the screen, I don't know if I can see my mouse there. There's this big line that goes all the way through New Zealand and down into the ocean. And pretty much where they join is essentially right down the middle of our country. So particularly exciting, particularly dangerous, but it makes for an interesting story. So you might have heard of the supercontinent Pangaea. So millions of years ago, all the continents were all hanging out together in one big landmass. So the southern part of Pangaea is what we call Gondwanaland. And I say this because I will probably mention Gondwanaland a little bit, because where we started is actually right off the side of Gondwanaland. So originally, so the basement rocks of New Zealand, which is the bulk of what New Zealand's made of, comes from what we call the Austral superprovince. And that's, you don't have to remember the name, but if you want to ever read about it, that's probably what it would be called. And you find these rocks, the Tuhua rocks, in the South Island. So where these rocks came from was off the side of Gondwanaland, in this big supercontinent of Pangaea. It started to erode, and we get the sediment, the sands, they all slowly coming down off the side into the bottom of the ocean. So you can see here that these two plates, there's one plate that's subducting underneath the side of the continent here, and what that's doing is, if you can see my hands, it's essentially all of these sediments are coming down off Gondwanaland, and then they're getting slowly pushed towards Gondwanaland. I've got a picture here. We call it the Tuhua orogeny, and orogeny is a fancy way of saying mountain building.
Oh, cool. Good to know.
That's supposed to be a slightly even fancier way of saying all those sediments coming off the side of Gondwanaland are getting squished right up against the side. So these are sediments that are from the ocean. So inside you'll find a lot of marine fossils, and I have a picture of one. So these rocks, the Tahua rocks, are part of the oldest rocks in New Zealand. This is the oldest rock in New Zealand.
Wow.
Or roughly. It's called Trilobite rock, and it's known for having lots of these little trilobite fossils inside of it.
Wow. That's cool.
Oh, yeah, I agree. They are awesome weed creatures, aren't they?
Hello.
Is Isabel?
Yay, someone else is here. More people.
And essentially, after this, we get the same thing happen again. So these are another part of this basement rock of New Zealand. And again, we're in the Carboniferous, so we're getting a little while back.
Whew.
So of the Murahuku rocks, these are the ones in red, and the Torles are the ones in yellow. And I'll have some pictures of them. So you can just sort of see roughly in New Zealand, we've kind of, those and the Tuhua rocks, we've kind of covered most of New Zealand by now. And the same thing is happening. We're getting all these sediments eroding off of the side of Gondwanaland into the ocean. And then they're going to get, oh, here they are. I'll go to the next slide quickly. They will get squished back up against the side of Gondwanaland. So these rocks, I've got the Murahuku rocks, which are interesting because they have, this guy is the oldest mammal fossil in New Zealand, which is a salamander, about
Wow.
200 and, I've got it somewhere, 45 million years old. And the oldest
Wow.
leaf fossils, which are, I think, 255 million years old, both of these are found in the Murahuku rocks.
They're so cool.
The Torles rocks, these come from underwater landslides. So all of these rocks are essentially getting eroded off the side of this massive supercontinent into the ocean, and then slowly, by the way of these plates moving, they're getting squished and squished up against the side, just plastered on, and then got all these cool fossils in them. So this is it here, just a picture showing of them all squished up against Gondwanaland now. It's a bit simplified. And also this diagram has two interesting geological formations that also happen to be part of this sequence of rocks. So one of them is the Haast schist, and it's kind of a small picture, but it's sort of down in the South Island. When it's getting squished against the side of Gondwanaland, it undergoes metamorphism. So it's really hot, and these rocks essentially get cooked, and they turn into new, harder rocks. And this is the Haast schist. And also, when it's getting squished up against the side of Gondwanaland, yes? Can I answer your question?
So just a quick question with this rock you've got here in this photo. Do you know what kind of rock it is? Like sedimentary, igneous, that kind of
So
thing.
this is a metamorphic rock, and specifically this one is a schist. And it's schist kind of tells you how much the rock has been cooked, and you can see that it's got very characteristic like lines through it, and that's something that you get when you have like a rock that's really rich in mud. So the minerals, they'll form these little lines when they get squished up.
So cool. I love the way it's telling us the story if we know what to look for. Would that be right? Yeah?
Yeah.
Amazing.
And also, you can look at it and tell how much pressure there might have been, or what the original composition of the mud that it came from would have been, which is all quite interesting.
Very, very cool. And I even love that idea that the rocks are falling off, but they're coming back, but
Yeah.
different, right? That's just, they're not new, they're the same things, but different. It's very cool, very clever, but kind of also not clever. It's just very cool hearing that story. It's amazing.
Another interesting thing is when we have the plate going underneath Gondwana land, it's a little bit of it scrapes off the side of the ocean crust. So ocean crust comes from the mantle, which means it's very rich in metals like iron and magnesium. So through New Zealand, there's a bit of a picture. There's a big sort of stripe of very, very metallic rocks called an ophiolite. So there's a little picture of it there. And I thought this picture behind it was really interesting because you can see that it's on the left because it's so rich in these metals that the vegetation doesn't want to grow on it.
Wow.
So in the South Island, it's a very striking feature because you see a big stripe of just no vegetation right along the side of the hills.
That's so cool.
Awesome.
Must be frustrating for everyone, but like it's very cool. Like they're trying to grow things. Just talking about rocks, yeah, and how New Zealand came to be is super cool.
So all these sediments that have come off the side of Gondwana land and now being squished on them, those form the basement of New Zealand. Now, the other part of New Zealand, so before we had the Austral superprovince, and this is called the Zealandia megasequence. They're kind of fun names. And this is the name given to all the sediments that are now getting deposited on top of the basement. So everything from 100 million years ago until today, these are part of the Kaikoura rocks. So we'll start at 10 million years ago. I'll start talking about what's happening and how we're getting these sediments to be on top of New Zealand. So 100 million years ago, around about, we've decided that we want to escape away from Gondwana land. We decided, goodbye, Australia and Antarctica. We don't want to hang out with you anymore. And this massive rift opens up. Where it once was subducting, it's now decided to move away. And there's a little picture here of how there's some volcanic activity and that causes the crust to thin. And all of those now Tahua rocks and Rangitata rocks are now making up base of New Zealand and are slowly moving away.
Was there a causal event that changed that subduction to going in the other direction, or just movement?
So there was the thinning of the crust, which obviously promotes the rifting. During this time, there was also a few tectonic changes, just globally. I'm not sure if it was roughly around this time, but if you might have heard that India, which is also part of Gondwana land, broke off and was colliding with Asia to make the Himalayas. So that was another big event that was sort of happening around these times. Again, related to, we're not quite sure what was happening, but there was some big tectonic changes, just globally. So this is a little her diagram from before, and we've said goodbye, and we've got the Tasman Sea now opening up in between Australia and what is early New Zealand.
Amazing.
So we start to rift away. Estimates for when we stopped moving away from Australia, I think, could be around 70 to 50 million years ago. So now New Zealand is actually slowly starting to sink. And this is called penetration, or essentially erosion of New Zealand is causing it to become really flat. And as it gets flatter, New Zealand starts to disappear beneath the water. It's not quite scary, I hope. This is part of when we have our Kaikoura rocks. We're seeing like rocks that start off being sediment from the land, and then you can actually look at like cliff sides and see rock that comes from land, and then a little bit of rock that might come from the beach, and then rock that comes from the ocean. So we can actually see in New Zealand rocks this record of it slowly getting lower and lower into the water.
So cool.
So at our lowest point of New Zealand elevation, it's sometimes called too as the Oligocene bottleneck. So New Zealand geologists have yet to agree whether or not New Zealand was still slightly above the water, or if New Zealand was completely underwater. So these two theories are called Noah's Ark and Goodbye Gondwana. So Goodbye Gondwana, meaning that we've said completely goodbye to all of our animals and flora that might have come from Gondwana, and it's all just underwater and hasn't survived. Or Noah's Ark, a funny play on Noah's Ark, is that there was some part of New Zealand that must have stayed above the water in order to preserve animals and plants that were originally on Gondwana and were carried along with us as we moved away. And I've got a picture of a tuatara because this is one of my favorite pieces of evidence towards the Noah's Ark theory. And they found a little piece of a tuatara jawbone in this lake in Otago. And it was dated to be just after the Oligocene bottleneck, which means that either it was the tuatara stayed in New Zealand all along, or it came to New Zealand a really short time after the sinking. And people think that it's very unlikely because tuataras can't swim, and they're not found anywhere else in other countries that were part of Gondwana land. So I think that means that the tuatara has been here all along.
Super cool. But is there evidence the other way as well? Is that why people are a little bit unsure about this? What's the evidence to suggest it was completely submerged?
A lot of the evidence is one suggesting that these animals didn't necessarily have to be here this whole time, that they might have been, that it was possible for them to have been brought over. Another one is some like birds. They're not necessarily have ancestors that were old, that like showed that they had been in New Zealand for a long time. So it's possible that we're looking at some animals that have been carried over.
Right. Oh, it's so interesting, isn't it? Very cool. Nia, did you have a question?
Does that mean we're eventually going to sink?
It is a good question.
I hope not. I hope I can answer your question right now, because at the moment we're undergoing a uplift phase, actually. So New Zealand's actually getting compressed, and we're moving up at the moment. So hopefully that means we're going to stay up. So this is called the Kaikoura orogeny, or the uplift of Kaikoura rocks. So this started right after the bottleneck. And it's because we got this new plate boundary, as I hopefully pointed out on the map earlier, through New Zealand. So hopefully you can see the Alpine Fault, which is the big plate boundary that goes right through the middle of New Zealand. So around this time, this is when we initiate our Alpine Fault. So this is when it starts, and it starts to move like that. And initially, it's just kind of moving sideways. But around 5 million years ago, we get another change in plate motions around New Zealand. So suddenly, where the Alpine Fault was moving like this, they're starting to move into each other.
Ooh.
And that means the Southern Alps are getting rapidly uplifted. And another thing that's cool about this is while we're rapidly uplifting, we're eroding some of those Kaikoura rocks. And this is how we've been able to see our basement rocks.
Ah, cool.
Now we're really just starting to see everything that's been under that.
Makes sense. Because, yeah, that is a question. How do you see those rocks that were in that basement zone unless they've been lifted up or you drill down? Cool. So they're quite young, the Southern Alps, then, comparatively speaking. Amazing.
Yeah.
And they're still going up? Are they still being pushed up?
They are definitely still going up. They're going up really quickly, actually.
Hey, what's quickly, geologically speaking?
I don't know the exact rate. I do know it's faster than other mountain ranges. And I do know that it's moving up so quickly that they're actually warm, relatively warm, because they're coming up from depth so fast that if you measure the temperature of the alpine fault, you'll see that it's actually abnormally warm.
Wow. That is very cool. Abby, did you have a question?
So, do you know a rough estimate of how old the Southern Alps is?
I would guess around this sort of 5 million year age is when I know that they were started to be uplifted. I think possibly older is when they started getting uplifted.
Very cool. Nia?
Do you think we're eventually going to drift back to Australia?
No, I don't want to be Australian.
At the moment, it doesn't look like we're going anywhere anytime soon. I think I don't really have a map of the tectonics with me at the moment, but I don't think that there's a enough of a subduction zone that's going to bring us towards Australia. I think we're moving away from them, or hopefully not going to end up Australian.
Awesome. Exactly. Nia, do you have another question?
Does that mean we're floating towards a different country?
That's a good question. So the movement on the Alpine Fault is still sort of still a little bit sideways. So, if anything, I think the two North and South Islands are going to get slightly further away from each other.
That's interesting. So that's the direction we're going in rather than sideways. If you think about a map, we're more moving up and down than we are side to side.
Because of the two subduction zones, things might start moving slightly closer to us, but I don't think it's going to be for a very long time.
Yeah, millions of years timescale, right? This is not like next week or when you're growing up. Like, it's a long way away. Phew. Amazing. Liam's in and out. Running stuff. Oh, good. All right, we got more. What else has happened geologically since the Southern Alps popped up? And keep popping.
So I've sort of got this last slide here, because these are sort of the most recent changes to New Zealand. So we've got some glaciers and some of the volcanoes, and this is my last slide, and these happened in the last sort of thousands of years. So
Wow.
this is compared to 500 million years. This happened yesterday, and this is also what's now ongoing. So at the moment, we're still within the Kaikoura orogeny. So we're still getting uplifted in the Alpine Fault. We're still seeing glaciers that are eroding our landscapes, and we're still seeing volcanoes erupting.
Absolutely true. I went to the Bay of Plenty for the first time in years and years and years and years recently, and I just about fell over because from the beach I could see White Island with a big plume of whatever you call it, steam, smoke, whatever coming out, and it's quite dramatic. It was very cool. So do you just want to tell us more about what those pictures are? Because I think Nia was asking, are they hot pools? What's the water coming off on that picture? Is it Emerald Lakes? Don't know if it is, Isabel.
I'm not entirely sure. I looked at a picture of a glacier. I thought
From
this
a
one was
glacier.
really nice, and I thought it particularly showed a little bit of the glacier eroding.
Amazing. Oh, you do think that's what it is. Amazing, Isabel. Very cool. That's awesome. Abby, did you have a question?
I was just asking if you had been there.
No. I wish that. It looks beautiful.
It looks very beautiful.
Absolutely does, doesn't it? Very, very cool. All right, who has questions for Jade? I've got so many. I think my head is absolutely spinning with them. But it's amazing, incredible, long, long history. But geologically, we're quite young. Quite amazing. Very cool. Nia, do you have a question?
Is there any other countries floating towards or away?
Great question. What else is happening geologically in the world?
I think one particularly interesting example of countries moving around is the East African Rift. Is right. It's essentially, like I said, how we were moving away from Gondwanaland. There's a rift that's starting in Africa, and not in anyone's lifetime, but eventually we're going to get parts of Africa sort of split open right in the middle of the continent.
Wow. Amazing. That is super cool. And what about the where India is crashing up into the bigger Asian continent? Is that still going on, like the Southern Alps, or is that settled down? Or
As far as I'm aware, that's still a active collision. That the Himalayas are still moving on up.
amazing, very cool. Abby, do you have a question?
What's one of your favourite things you've discovered that's happening in New Zealand? Like with this topic.
Oh, that's an interesting question. I on the topic of rifts, actually, in sort of Taupo, that's also a rift. So that's the reason why you'd get a lot of volcanoes there is because the crust is getting thinner. So the research that I've been doing at the moment is I've been sort of looking at what the mantle looks like underneath sort of the side of the North Island. And what we've found is that actually that one, that it's sort of where the plate is subducting, you sort of get the mantle moving along the sides of it. So I think that one's pretty interesting.
Cool.
That's a discovery that I think I'm making at the moment.
Amazing to be involved in that. That's really cool. Nia, was that your hand up? Sorry, no. Amazing. Okay, fantastic. Look at that. We're actually on time, folks. This is probably a first for the entire week. Amazing. Thank you so much, Jade. That was so interesting about our wee young country that's moving all over the place and crashing up new mountain ranges. So very, very cool. So much to think about there. I love that phrase, Noah's Ark. That is one I'm definitely going to take and have some fun with. Fantastic stuff. Right, emoji spam o'clock, folks. Give Jade a great big yes. Emoji spam, go for
Thank
gold.
you, Jade.
Amazing. Thanks so much, Jade. Have a great rest of your evening, folks. We've got Women in STEM at 7:30 if you are still around. All right, folks. See you
Thank
later.
you. Thank you.
Bye.
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 Bye.